Hello everyone and welcome back. In a previous video, we wrote some starter code for a project called Web Services Fun that is an Android app that fetches interesting photo information and source images from the Flickr API. If you go to flickr.com/explore, you can see the interesting photos of the day. And these are the photos that we're going to request and display in our app so that we can appreciate these beautiful photos in our Android app. Now, a little bit of a review from last video of how APIs work. Our app has to create a request to an API server. If the request looks good, the server will essentially package up the data that we requested and send it back to us as a response. We then need to parse that response. All of this can take some time. It might be less than a second, it might be a couple seconds, it could be even longer. And for that reason, we don't want to run this code that makes the request and parses the response on what's called the main UI thread that keeps our interface live and updated and responsive for our user, because if we do, we could overload it and then we will essentially have a UI that hangs or freezes, and that's not a good user experience. So that means we're going to learn a little bit about threading. If you're not familiar with threading, no worries. Here's a super high-level overview of a thread. A thread is essentially a sequence of code that executes inside of an existing process. Here's a simple diagram of a process that contains two threads. The threads over time are scheduled as the process is scheduled by alternating and completing different tasks. The threads are essentially alternating so fast and the process is being scheduled with other processes on your CPU or CPU so fast that if this is all set up properly, then the user is not even going to notice that essentially our UI thread and our background thread are alternating execution really fast. So our goal then is to learn a little bit about background tasks and how we can set them up to run on a different thread so that our main UI doesn't freeze up while we're trying to make this request and parse its response. To do this, we're going to use what's called the AsyncTask class from Android. This was added in API level 3, and I'll note that it was deprecated in API level 30 at the time of this video recording. The current API level is 31 that just came out about a month ago or so. So this really was recently deprecated. I believe this deprecation is part of a larger movement to try and get people off of Java and onto Kotlin for Android development. Because if you look here, it says use the standard java.util.concurrent or Kotlin concurrency utilities instead. Well, we don't want to use java.util.concurrent. What we want to do in the future is move over to Kotlin. So let's use AsyncTask. It'll work just fine for demonstration purposes and learning as we essentially close out our Java usage in Android and start migrating to Kotlin for these better concurrency utilities anyways. These ones are really old. So I'm going to head back to our source code. Here's where we left off last video. We had just created a Flickr API object and called fetch interesting photos, which is going to essentially create the request, make the request, get the response back, and parse the response. Here's fetch interesting photos. We have just created the URL. We printed it out to Logcat. We opened it in Google Chrome or your favorite web browser, and we were confident that our URL is correct because we were getting JSON data back, and the data that contained was the photo information we wanted, like the title, the date taken, an ID, URL, etc. So let's take a little bit of notes about what we have to do here next. Essentially, we have to start a background task to fetch the photos for reasons I just mentioned. Even if we wanted to do this on the main UI thread, Android wouldn't let us. We actually have to use a background task anyways. So it's good practice so our UI thread doesn't get overloaded and freeze up, but it's also required if our background task we want to run involves doing anything with network activity. So Android will not let you do any network activity, which is what we're doing when we're using the internet to make a request and get a response back on the main UI thread. So what we do is we define a subclass of that abstract async task class that I just showed you in the documentation. Async is short for asynchronous, which essentially means that the code that calls the async task to start executing is not going to block or wait for a response back. It's going to start it on another thread and then carry on with what it needs to keep on carrying on doing. So asynchronous means doesn't wait or block. It'll start it on another thread, and then the main UI thread will continue doing its main UI thread things. So I'm going to scroll down just a little bit here, and I'm going to make this class. I'm going to call it fetch interesting photo list async task, which is kind of long and a mouthful, I know, but we're really descriptive about what this class is going to do. It is going to be a subclass of AsyncTask, which has 3 parameterized types. The first one will be a string, which represents the type of the arguments that are going to come into our essentially execute method. Next is going to be a type that represents how we're going to update our progress to the user. We aren't going to update progress to our user in terms of like measurable chunks like 50% of 100% or 5 megs of 10 megs or something like this. We'll just show an indeterminate progress bar, which is essentially a circular spinner that just keeps spinning while we're doing something in the background. And then the last parameterized type here is going to be what we're going to return to code on our main UI thread for displaying or using once this async task is done and successful. So that is going to be a list of interesting photo objects, which we have not declared yet. So let's do that. Right click on our package, new Java class, interesting photo. Interesting photo is going to be a class to represent the minimum information that we need for an interesting photo from Flickr in order to display content in our app for our user. So this includes a string ID, a string for the title, a string for the date taken, and a string for the photo URL. And then from here, I'm simply going to stub out the rest of this class, meaning an explicit value constructor, a toString getters and setters with the IntelliJ shortcuts. Awesome. I'm going to import java.util.list, and then this is not compiling because there's one abstract method that we have to have, which is called doInBackground. So let's add that, doInBackground, and now our code compiles. DoInBackground is essentially the method that executes when we call execute on an fetch interesting photo list async task object. We're going to pass in a list of strings. For us, it'll just be one, which will be our URL. And those are going to come in as what are called var args, or variable arguments, which we can essentially just treat like an array. So let me make a few notes in here. So fetch interesting photo list async task is a subclass of async task, which executes on a background thread. We cannot update anything on the UI thread, like our UIs, our UI elements like our text views, our image views, etc., unless we are in the appropriate async task method, which we will see here momentarily. DoInBackground, as the name implies, is going to run on the background thread. We cannot update the main UI thread from this method. So in this do in background, we're going to do 3 things. The first thing we're going to do is open the URL request. The second thing is download the JSON response. And the third thing is parse the JSON response into interesting photo objects. We'll put all those object references into a list, and that's what we will return. You know this is what we're going to return because look at the return type for do in background. This came from our third parameterized type on our header here. So let's call this method. Here's fetch interesting photos. We will make a fetch interesting photo list async task object. Then we'll call AsyncTask.execute. We don't call do in background, we call execute, and then all the proper thread, memory, etc. is set up for us. So we'll call execute, and we can pass in a variable number of string parameters because that was the first parameterized type on our fetch interesting photo list async task header. For us, all we're going to do is pass in URL. So this will be the string at element 0 in our var args right here in do in background. So let's grab it. And I can make a little note here. The string ... is called var args, and we can treat it like an array for a variable number of arguments. So we'll grab URL. Our goal is to produce a list of interesting photo objects. So let's create that list, hoping everything goes well and we're able to return it. So let's create a java.net.url object to represent our URL that currently is a string. This can throw an exception, so we'll need to add a try catch block to catch a malformed URL exception in case the string we pass in is not actually a valid URL. It can't be parsed into our URL. Once we have a URL object, then we can pass that into, or excuse me, we can call open connection on that URL object in order to attempt to get a HTTP URL connection. So HTTP, and we can use HTTPS, by the way, because if you look at our URL, we're actually using HTTPS. So we'll use HTTPS URL connection. URL object, here's the key part here, dot open connection. So open a connection to this URL using HTTPS. So this can also throw an exception. That's why we're getting an error here. So we'll add a catch clause for IO exception in case we're not able to connect to this URL. This could happen if, for example, internet is down. Now that we have the URL connection, what we want to do is attempt step number 2, which is download the JSON response. So if we're right here, we didn't end up in the second catch, and we can attempt to download the JSON response. So we'll get a string from the response. We'll have to build this up character by character. There are libraries out there that make this easier to do, but we're just going to use the standard libraries to do it. So it'll feel a little clunky, but we'll get through it. We're going to build the JSON string from an input stream. So let's get the input stream. So we'll do URL connection dot get input stream. So this will block and wait essentially for the input stream to be initialized and connected. And then we'll need an input stream reader in order to read from the input stream. And now let's attempt to read data from the input stream reader. So we'll call read, which returns a single character. If this fails, then data will store -1. So while data is not equal to -1, we'll do JSON result plus assign, typecasting that integer to a char, building up our string character by character. And then here's our progress towards our Boolean condition being false. So let's write this string out to logcat and make sure that it looks good. We should match what we saw in the browser when we opened this URL with Chrome in our logcat. Takes a little bit of time, which is why we're running it on a background thread. There it is. And look, it matches exactly what we saw in Chrome. So here's our photos root object. There are 5 pages. We have data for the first page with 100 interesting photos per page. And then here are the interesting photos themselves. This is what we want to parse out. We want to get this photo array and then go through each single photo object, grab its ID, grab its title, grab its date taken, and grab its URL_H, which is right here. So that's our next big task. So now if we're here, we were successfully able to get a JSON result. And what we want to do is now parse the JSON. So we'll use JSON object, org.json is the package. We'll create a JSON object from this string. This will be nice because then we can call methods on the JSON object like get JSON object, get JSON array, etc. This can also throw an exception, so we've got to add another catch clause here. So we'll add a JSON exception. If this is not actually a valid JSON string, then we won't be able to parse a JSON object from it. Okay, so here with JSON object, now what we want to do is first grab that root photos JSON object, the one right here, to get this JSON object. So another JSON object, I'll call this photos object. Okay, now we have the photos object. From the photos object, I want to get the photo array. So this will be a JSON array. So just to be really clear, I'm not making up these strings here. In the first case, photos is the key. I see that from the JSON. And in the second case, photo is the key. And it's interesting because photo gives us the array of photos, even though it's named singular. So we have to look at the JSON response in order to know what keys we put in here. Now with the photo array, we can walk through each photo object in the photo array and attempt to parse out an interesting photo object, truly the interesting photo type that we created earlier, and then put it into our list and then return the list. So in here, we'll grab the single JSON object for a photo. grab the JSON object at index I, and then try to parse a single photo's info. Let's write a method to do this. We'll call it parse interesting photo, passing in our single photo object. And if anything goes wrong in this method as we attempt to parse out our needed data, we'll just return null. So we should check to make sure that we were able to get all of our information by testing the interesting photo is not null from this method we're going to write here in a moment. If it's not, then awesome. We can add this to our list. And we will return this list right down here. So let's define this method here. It's going to return an interesting photo. Hopefully, it will return null on failure. We'll pass in a single photo object represented as a JSON object. Like I said, if anything goes wrong, we'll just return null. And a lot of things can go wrong. We're going to be calling getString on our single photo object if we pass in a key that is not actually in the interesting photo for whatever reason. The most likely reason this would be our URL H that we requested is not available for this particular photo. Then a JSON exception is going to be thrown. What would be good is to print out stack trace and or try to request a different URL. What we will do is nothing. If we can't get all 4 pieces of information that we need from an interesting photo, then we'll just skip this photo. There'll be lots of other photos that we can display. And we'll see how many out of the 100 that we can successfully parse. But if this was a production application, then we should try to do something here to recover. So let's start with the ID. We don't really need the ID because we're not going to display it in our UI, but it's always good to store the ID in case we needed it later for perhaps we're trying to request a different URL or trying to do something with it. It's just good practice to get the ID because it's a unique identifier. There could be overlapping titles or date takens, but the ID will always be unique. So it's always good practice to grab that. So we'll try to get a string, ID, okay, and I'm just grabbing this string right here out of the first element keys. So ID, next we'll grab title, next we'll grab date taken, and this one's tricky because when we constructed our URL, scroll up a little bit here, date taken had an underscore here, but in the response, date taken doesn't have an underscore. So that's why it's always important to read the documentation and look at the JSON that you're attempting to parse. And that's where that pretty printer can come in handy too. And then last, but certainly not least, URL underscore H. So this is the one that's most likely to fail, this line here, if the URL underscore H isn't available for this particular image. So if we can get this, awesome. Then we got all 4 pieces of information we need in order to create an interesting photo object. Scrolling up a bit here. Here's where we're calling parse interesting photo, adding it to the list if it's not null, meaning we're able to grab all 4 strings that we need from the object. The return type on this do in background is list interesting photo, which is what we're returning right here. So where does this go? If we head back to the asynchronous task reference on the Android documentation, there are 4 steps. When an asynchronous task is executed, the task goes through 4 steps. On pre-execute, which we did not override, do in background, which we did override, on progress update, which we didn't override, and on post execute, which we didn't override. What's interesting is do in background returns a value. That value is the result of do in background, and it's going to be the parameter to on post execute. On post execute is a method that runs on the UI thread after the background computation finishes. And like I just said, the result of the background computation is passed to this step as a parameter. So result, which is our third return type and our 3 parameterized types right here, list interesting photo, this is going to be the parameter type for our last method here in the 4 steps on post execute. The only one of these 4 you have to override is do in background because it's abstract. So if you don't need 1, 2, or 3, or excuse me, 1, 3, or 4, then you don't have to override them. But we do need 4 because the result from do in background is the parameter to on post execute, which runs on the main UI thread, which is where we can essentially call our main activity a callback and essentially pass it back. So inside of our AsyncTask subclass, I'm going to bring up our override methods again, grab on post execute. Notice how it autofilled to have our parameter type be a list of interesting photo. This will be a reference to this list right here. So what do we want to do here? Let's do 2 things. Let's first write out a log message with interestingphotos.size so we can see how many that we can successfully parse out. Hopefully it's close to 100. And then we've got a reference to main activity. So let's call a method that we'll write here in a moment called received interesting photos, and we'll pass in interesting photos. This will be a callback method, essentially a main activity that we call to say, hey, main activity, we're done with the background work. Here's the interesting photos you asked for a while back. Now you can do something with them. So in main activity, let's write this method. Let's run this and let's see how many interesting photos we get. And remember, this takes a little bit of time. Here we are on post execute. So we were successfully able to parse 91 photos, which is awesome. We don't have the actual source images yet for them. We just have their URLs. But we can at least start some work in main activity here in order to show the title and the date taken, and on fab floating action button click, be able to flip through them. And then the last thing we'll have to do is go fetch essentially the source image from the URLh for each current photo. We will do that last. So I'm going to head up to the top of main activity and I'm going to add 2 attributes here. I'll do a list of interesting photo objects. And I'm also going to add an integer called current photo index, which will start out as -1. This will represent where in this list we currently are displaying a photo to the user. So in receive interesting photos, I'm going to set this dot interesting photo list to the parameter interesting photo list. And then I'm going to call a method called next photo, which is essentially going to do all the work to set up our UI to display the next photo. I'll also call next photo from our floating action button on click listener so that whenever the user presses the fab, next photo will execute, and this will set up everything we need to display the next photo. So let's do a little bit of checking here. If the interesting photo list is not null, meaning we were successfully able to parse some interesting photos, and the interesting photo list dot size is greater than 0, so it's not empty, then what we want to do is increment our current photo index. If we started at -1, then this first call right here will bring current photo index to 0, which will be our first valid index. We have 91 photos currently, but on any given day, we could have a different number. So if the user ever clicks through all of them and truly gets to 91 as an index, then we should wrap this around to 0. So I'm just going to update current photo index to mod by interesting photo list dot size. That way, like I said, if they ever get to the end of our list, we'll just wrap it around to 0. I'm going to get references now to our title text view and our date taken text view that we set up in a previous video in our constraint layout. Grab the interesting photo, add index current photo index, and now update the title text view and the date taken text view. I'm gonna make a little to-do here so we don't forget. Come back and add support to fetch the source image using interesting photo.get photo URL. That'll be the URL_H string that we parsed out over in Flickr API. Let's try this. Like I said, right now we're not gonna have any support for seeing the actual photo images themselves, but we should be able to flip through and see the title and date taken for all 91 images we're able to parse out right now. Looks like it's done. Let's take a look. So there it is, Atomic Explorer number 1, that's the title, and then here's the date taken. And I can click on my floating action button and flip through and see all 91 titles and date takens. So far, so good. Let's do one more thing before we move on to our last to-do here. Back in Flickr API, we've overridden on post execute and do in background. We can also override on pre-execute, which is invoked on the UI thread before the task is executed. This step is normally used to set up the task, for instance, showing a progress bar in the user interface. This is exactly what we want to do. We want to show a progress bar in the user interface while our do in background is executing. So we can bookend do in background with on pre-execute, which runs on the UI thread, will show a progress bar. And we can bookend on the other side, do in background with on post execute, where we can remove the progress bar, because this runs on the main UI thread. If you're interested, I put a link to material design on progress indicators, so you can take a look at all the different progress bar options that we have out there. We'll use a simple one, which is a simple indeterminate circular progress bar. So it'll look like this, a circular indicator, and it's indeterminate because there's essentially an unspecified amount of wait time. We don't know how long it's going to take to make the request, so therefore the progress isn't detectable, and it's also not necessary to indicate how long the activity will take. If you have essentially progress that is detectable and you know how long it will take, then you should use a determinant indicator, which essentially goes from 0 to 100%. And if you want to do this, then AsyncTask has a step 3, with a method on progress update, where you can essentially publish your progress to the main UI thread. So that's kind of fun, something to take a look at if you're interested. So let's add a progress bar. I'm going to go back to our constraint layout here. I am going to drop out of this presenter view in order to add our progress bar, because with the design editor, sometimes everything is just a little too big to show on my laptop. So let's find a progress bar. Here's our circular one. We can drag it out, and we need to constrain it. So I'm going to head up to the constraint widget, and we can simply constrain it to just be centered over our image view. That would be easy to do. And it looks like some of these went to the parent, so I'm just going to drop down into XML real quick here and fix this. So I want top to top of image view, start to start of image view, end to end of image view, and bottom to bottom of image view. Let's see how that looks. Awesome. So it looks like it's going to be centered over our image view. And now the only thing left to do is give it a nice ID. So I'll just call it progress bar. And head down to visibility, or head over to XML and set Android visibility attribute to be gone. I don't want it to be displayed until on pre-execute executes in my Flickr API fetch interesting photo list async task. So I'm going to override on pre-execute. This executes on the main UI thread, so I can safely get a reference to that progress bar. This will be main activity.findView by ID, progress bar.set visibility to visible. Now I need to do this same thing in on post execute, but I need to make its visibility back to gone. Probably do this after main activity has updated. So I'm going to launch this and then immediately head over so we can see that progress indicator. Looks like it's spinning, and as soon as we get all 91 of our photos parsed, then it should go away. And it looks like it did. Awesome, we're so close to being done. All we have to do now is fetch the photo, the true photo source image, whenever we flip through to the next photo. So that's the to-do that I left in main activity right here. Essentially, the game plan for this is to define another asynchronous task subclass, attempt to get a bitmap that represents the image from the server, and then display that bitmap in our image view. Rather than deriving that code, I'm going to simply paste it in, I'll explain it, and then we'll run it and we'll be done with web services fun. So let me go ahead and grab that and move it into the project. I've just pasted the rest of the code we need to finish the app to add support to fetch the source image. So what I did here in our next photo method is I created a new Flickr API object, and I called fetch photo bitmap, passing in interestingphoto.getPhoto URL, which is the current interesting photo we're about to display to the user. So let me show you that method. Here it is, fetch photo bitmap. We've got a string for a URL. I create a new photo request async task and call execute, passing in photo URL, following the same template that we did earlier for this big class up here called fetch interesting photo list async task. So here's the class. On pre-execute, I show the progress bar again. On post-execute, I remove the progress bar. Do in background attempts to open an HTTP URL connection for that URL. I've got an input stream here, and I just use this convenience method, decode stream from bitmap factory to get a bitmap. And if everything goes well, I return bitmap. Otherwise, I return null. Down here and on post execute, here's a reference to that bitmap that hopefully isn't null. If everything went well, I pass this bitmap reference to a callback and main activity called received photo bitmap. And then over here in receive photo bitmap, this is where I have the reference. I grab a reference to the image view, and then I use the bitmap reference to set the image view's image bitmap. So let's run this and see the whole app in all of its glory. So here it is. We've got the progress indicator spinning while we are fetching all of those interesting photos information as JSON objects. When we get the first one, in addition to seeing the title and date taken like we saw earlier, we should also see the image. There it is. So let's flip through a few more of them. Now, as I flip through them, notice that there's a brief amount of time where I'm showing the progress indicator while we're fetching the next photo, but it really doesn't take all that long to download that bitmap. So there they are. We did a lot in this video and in the previous video where we did our setup and created our URL. Essentially, the big picture is this. There are servers out there that are running services for third-party developers and applications like ourselves to make requests for content. Now, if we read the documentation for that service, we can figure out how to structure our request such that it's valid and we can get a response back with whatever content data we want. We have to parse that response like we did with all that JSON work in order to get it in a form that we can then use in our app. But this is essentially how a lot of apps are built. APIs are building blocks, and you can piece them together to make your app highly functional without needing to reinvent the wheel. So think about services like Google Maps. How many apps have Google Maps in it that aren't essentially written or maintained by Google? A lot. That's because Google Maps has an API. It also has often an SDK, software development kit, for developers to use to incorporate that app services into their own app. So really, like I said, APIs are the building blocks of building apps with a lot of functionality. And with this in your back pocket, I encourage you to go to a GitHub repo called github.com/public APIs, because this is a really great place to get started working with APIs. It's essentially a crowdsourced list of free APIs for use in software and web development. And it's got a really nice table of contents with all these different categories. So for example, if you're interested in blockchain, you can see all of these APIs available to the public that you can use to start making requests for information about blockchain. Just using that as an example. So take a look here to get some great ideas for how you can increase the functionality in your app by using existing services out there via their APIs. That's it. Thanks for watching, and please subscribe to see more awesome videos like this to help you with your software development. Thank you.